Hi, welcome back to Mrs. Thompson's classroom. Today we're going to continue talking about linear functions. In particular, we're going to look at parallel and perpendicular lines. So parallel lines, let's first define what they are. They look like railroad tracks, right? In specific, they never intersect. Okay, now this implies that their slopes are equal. Okay, so in order to decide if lines are parallel, we're going to have to find their slope. So when they're written in standard form, like these three are, we're going to need to either, we can solve for y. This tells me that our slope is -2. Or we can remember the rule that when we solve for y, we end up taking these coefficients and the slope will equal -a over b, where a is the coefficient in front of x and b is the coefficient of y. So we end up with -4 over 2, which is -2. In the third one, we'll have -1 over 2, so we get -1/2. So the two that are parallel, we suspect are 1 and 2. This one is not. Now we do also need to check that they're actually not the same line, so we need to look for that y-intercept. So here the y-intercept is 5. For this one, the y-intercept occurs when x is 0. So that'll give me 0 plus 2y equals 20. So my b value is y, which is 10. So because these are not equal, we are not the same line. So we have equal slopes and not equal y-intercepts. So number 1 and number 2 are our parallel lines. Okay, now they might also ask us to write the equation of a line that is parallel to a given line. So the first thing I do is I take my given line and I find its slope. That means the parallel line is also going to have a slope of 4. So then I write my point slope form of an equation, and I take the point they gave me and I plug in the y and I plug in the x. So we get y equals 4 times x minus 2 plus 1 is my equation. Now some people like to simplify that out, so we can distribute the 4 and we end up with y equals 4x minus 7 in slope-intercept form. Either of these are fine answers. They're equivalent equations. Okay. All right, so the next thing we want to talk about is perpendicular lines. Now, perpendicular lines make a T, right? They make a right angle. That means they intersect at 90 degrees. So what does this mean about their slopes? Well, first of all, one's negative and one's positive, right? In order to make a right angle, they have to be going opposite directions. What we also find is that our rise and run actually are going to have to switch places in order to make that right angle. So in order to make, if the slope is a over b, then the perpendicular slope is going to be -b over a. And what we call these are negative reciprocals. So what I tell my students all the time is we're going to flip and switch. Okay, we're going to flip the slope over and we're going to switch its sign. Okay, so what is the slope of any perpendicular line to this equation? So the first thing I do is I find the slope. So the slope of this one is going to be -2 over 3. That's going to make my perpendicular slope, this little upside down T means perpendicular, is going to be a positive 3/2. Okay? So it's as simple as that. We take the slope of the original line, we flip it over, and we change the sign. Okay? Now they might want us to write the equation of a specific perpendicular line, but I still am going to start by finding the regular slope of the given line. So this would be -1 over -2, so that's a positive 1/2. That makes my perpendicular slope equal to negative, since this one's positive, and I flip it over to 2 over 1, so I get -2. So then I come over here to this point they've given me, and I write my point slope form of the line. So I put the 3 in for y, the -1 in for x, and I get y equals -2 times x plus 1 plus 3. And if we want to reduce that out, we'll get y equals -2x minus 2 plus 3. So we get y equals -2x plus 1. This equation is slope-intercept. The first one we found was point slope. Okay? All right. Now, slope is a rate of change. That it is change in y over change in x. So if our y is in miles and our x is in hours, we'll get miles per hour. Or maybe y is measuring volume over a given time. We've got a bowl that's leaking. But they're rates of change. Okay, so when we're talking word problems in units, the units of a slope is always going to be this fraction. So let's take a look at this example. We got John traveling to his grandmother's house. At 1 hour, he's 50 miles from home. Okay, it takes 5 hours to travel the total 330 miles. So after 5 hours, he's gone 330 miles. Notice our points are, we have time and then we have miles. Okay, so what is the slope between the values? So we're going to take our y values and subtract them. And we're going to take the x values and subtract them. So that gets me 280 over 4, so I end up with 70. Now the question is, what does this represent? Well, let's look at units. So the 330 and the 50 are in miles. The 5 and the 1 are in hours. So what I have found is miles per hour. So what this is representing is his average speed over the 5-hour period. Okay, so slope gives us a rate of change is the point of the problem. So a lot of times we'll put these into actual scenarios in word problems, and we know that it's a rate of change because it ends up being a unit per another one. It may not ask us for the slope. It may have asked us to find the average speed. Okay, all right, so average rate of change can be done with any function. All it means is we're going to find the slope. So we'll find the difference in y's over the time interval and the difference in x's. So f of 1 is 1 cubed plus 1. F of 0 is 0 cubed plus 1. So when I calculate this out, I end up with a rate of change of 1. Okay, now we don't have any units on this problem, but maybe F is in meters and X is in seconds. And so this would be in meters per second. It is a rate of change, and it's the average because we looked at how it was changing over some time interval. So from 1 to 2, it will be F of 2 minus F of 1. And again, we plug these x values into the original function. and we get 7. Okay, they're different average rates of change because they were on different time intervals. Okay, now let's go all the way from 0 to 2. It's probably going to be somewhere in between 1 and 7. The first time interval is bringing my rate down, and then in the second time interval, I sped up. So we're probably going to be somewhere in between, but I'm going to do this the same, so I'll take f of 2 minus f of 0 over 2 minus 0. Okay. So f of 2 is 2 cubed plus 1. F of 0 is 0 cubed plus 1. So I end up with 9 plus 1 over 2, which is 5. Okay. All right, so the last thing, no, actually not the last. We're going to do 2 more things. One, we're going to put this into using a data set. So sometimes in the real world, we don't have equations, right? We have a set of values that maybe we've conducted an experiment or something, and we have this information, and we need to do something with it. Well, the first thing we might do is do a scatter plot for the data to see what it's looking like. So we're going to put it in our calculator. You can use this stat button to edit your list and put in your data. And notice I'm letting 1980 be year 0. So this is year 0, 10, 20, and 28. Okay, then we're going to turn our stat plot on. Notice this stat plot here above the y equals. We're going to turn our stat plot on. We're going to check our window to make sure the x max and y max are big enough to include all of these data points. So I went up to a y of 60. Okay? And then we hit graph and we see our points. Now we notice that it looks like I could draw sort of a line through them. And so part B wants us to actually find the equation that would model the data. So I'm going to write my points. In 1990, that's year 10. And in 2000, that's year 20. And if I find the slope between them, I end up with 0.65 for my slope. So then for part B, when it wants me to write the equation, I'm going to get y equals my slope times, and I'm going to go ahead and use this first point here. And this equation would model the data points. Now, it's not precise. It would not go through every point, but it would allow us to do part C, which is to try to predict in 2015. Now, that'll be year 35 years after 1980. So what I'm really going to do is I'm going to find y of 35. So I'll have 0.65 times 35 minus 10 plus 45.2. So we'll have 0.65 times 20. Okay, and so that'll end up being, let's see, well, I think it's approximately 61 point something. You can plug that into your calculator and get a result. Okay, now, part D wants us to do this equation in the calculator. Now, this equation just used a random 2 points. I picked whichever ones I wanted. The calculator is going to find what's called the line of best fit. And we do this with a linear regression. So what we're going to do is we're going to go back to that stat button, and we're going to go to calculate and choose option number 8 and do a linear regression. And it's going to bring this up. You're going to choose list 1 and list 2. Notice down here on your calculator screen, you can see L1 and L2. Okay. I've also chosen to store the equation so I can graph it. You can do that using your vars button. hit vars, choose function, choose y1 or y2, wherever you want to do it. And then we're going to calculate. So what it spits out for me is my equation, and it'll be y equals 0.89447x plus 34.20519. Now you can go out as many decimals as accuracy as you need for the given situation. The more decimal places you leave, the more accurate your answer will be. Right now, if you want then to predict the value in 2015, we can plug 35 in for x. Your calculator will also do that for you if you choose second, calculate, option 1 is value. And then you can simply type in 35 and it'll spit out your answer. And so y of 35 is going to be 65.5116. Okay, so it's not exactly what we got in answer C, and it shouldn't. Notice the line that it drew, because I stored it, it graphed it for me, went through at different 2 points than the 2 I chose. This would be 1990. And this would be 2000. These are the 2 I chose. But the line of best fit chose these other 2 points. Okay? So it's not going to be precise. Now notice when you use this second calculate value, your window has to include the 35 that I'm typing in. That's why this picture doesn't look exactly like the previous one, because I had to change the window a bit. Okay? All right, now we're on the last thing, which is our difference quotient. Now, difference quotient is a formula that looks like this. It's actually a value that we will use in calculus class to help us with derivatives, because it's helping us with a rate of change. It's actually helping us find the rate of change of the tangent line at a specific point. But for now, here in pre-calc class, we're just going to do this calculation. So I'm going to take f of x plus h, and then I'm going to subtract f of x, and I'm going to put it all over h. Okay? Now sometimes we can simplify this, and sometimes we'll have to just leave it, but this one we can do some algebra on. I'm going to FOIL this out first, x squared plus 2xh plus h squared. Then I'm going to distribute my 4. Then I'm going to distribute the negative, and it's still all over h. Now I'm going to go and reduce some things. So I notice that 4x minus 4x goes to 0. Negative 1, oops, this would be plus. Negative 1 plus 1 goes to 0. And x squared minus x squared goes to 0. So what I'm left with is this quantity. And then I see that they all have an h. Okay, and so my final answer is 2x plus h plus 4. In calculus class, what you'll find out is the derivative is this 2x plus 4. The h is going to end up going to 0 as we find that tangent line. All right, so for this next one, again, we'll just put in the x plus h, and then we will leave the f of x as it sits and divide by h. The bigger this exponent gets, you may not want to simplify this out. This one does end up going like this when I cube that out. And so I end up with 2x cubed plus 3x squared h plus 3xh squared plus h cubed. So the 2x cubes go away and the 3's go away. Everything else has an h, so my final answer is 3x squared plus 3xh plus h squared. So the derivative that we'll find is this 3x squared part. Okay? So take some time to practice those things. If you're in class with me, you have your worksheets to do. And just be sure if you've got questions to comment below or come to class prepared to ask them. And hopefully we'll see you next time when we start working on some higher ordered polynomials. We'll do quadratics first and work our way up. But we will see you then, and hopefully this is helping.